Okay, I've got a power supply and I've got an oscilloscope. Okay, I can use my oscilloscope to look at the signal, right? I'm going to connect the alternating supply. So it's going to be continuously changing polarity. Okay, when I turn that on, I should be able to see what signal I've got. I've got to connect the oscilloscope to these, my output, as it were. This is my output at the moment. There's no load on the circuit, so not having a load on the circuit isn't very clever. I'm going to put a resistor in there just so that the circuit's got something to do. So the whole point of the circuit is to transfer some energy, so it needs to do some work. So it's going to do some work through this resistor. In reality, that resistor is just going to get hot. It's not doing anything exciting. But I can describe that resistor as a load on the circuit. Okay. If I want to see what the signal is like from my supply, I can connect my oscilloscope in parallel. I'll turn it on, okay, and then I've got an alternating current on my oscilloscope. Lovely, okay. Now, I want to show you what happens if I put a diode in that circuit. So if I unplug the resistor, okay, I'll keep that plugged in there. I'm going to put a diode in. If I connect from that diode to that point there, look at that. What's happened to my signal? I've lost half of my wave. Okay, if I bypass the diode, there's my original signal. Pop the diode in, and now I've truncated my alternating current. I've lost half of my wave. Half of my wave has disappeared. That makes sense. Diodes only allow current to flow in one direction. Okay, neat.